In a groundbreaking development that has stunned astronomers worldwide, NASA's James Webb Space Telescope has revealed phenomena that challenge our deepest assumptions about the universe. Only weeks after detecting one of the earliest galaxies ever observed, the telescope has now spotted an even more extraordinary event: a supermassive black hole moving away from its host galaxy at an astonishing speed exceeding 4 million miles per hour. This revelation has sparked intense fascination and debate across the scientific community, as it could reshape key ideas in astrophysics and cosmology. Since its launch, James Webb has been humanity's window into the universe's infancy, exploring the first stars and galaxies to emerge after the Big Bang. Its infrared instruments have captured the grandeur of dying stars, colliding galaxies, and now, a phenomenon that defies conventional understanding: a black hole that seems to create rather than destroy. Unlike typical black holes which consume surrounding matter, this runaway black hole appears to leave a trail of star formation in its wake. As it barrels through space, it compresses and cools nearby gas clouds, triggering bursts of new stars along a luminous path stretching more than 200,000 light-years, far wider than the Milky Way itself. This discovery not only challenges traditional models of black hole behavior but also hints at entirely new mechanisms for how stars can form. The findings, published in the astrophysical journal Letters, were led by astronomer Professor Peter van Dachem and supported by complementary observations from the Hubble Space Telescope, reinforcing their credibility. Rather than absorbing light as expected, this black hole appears to stimulate star formation, carving a brilliant cosmic wake as it moves through a vast reservoir of interstellar gas. But Webb's revelations didn't stop there. Another stunning observation involves ARP 220, one of the most spectacular galactic mergers known. This ultra-luminous infrared galaxy radiates with the energy of roughly 1 trillion suns, vastly outshining the Milky Way's 10 billion sun luminosity. Situated about 250 million light-years away in the constellation Serpens, ARP 220 represents the most energetic galactic collision in our cosmic neighborhood. Around 700 million years ago, two spiral galaxies collided, triggering a massive starburst. The merger created a compact, ultra-dense region spanning just 5,000 light-years, yet containing as much gas and mass as the Milky Way. Previous radio observations revealed over 100 supernova remnants within only 500 light-years, a testament to the galaxy's intense star-forming activity. Webb's advanced infrared sensors have now captured the clearest images yet, revealing two luminous galactic cores roughly 1,200 light-years apart, each surrounded by rotating rings where stars continue to form. Tidal tails stretch outward from the merging system, evidence of the violent gravitational interactions during the collision. Intriguingly, red and orange filaments of organic material weave through the galaxy, adding a chaotic vibrancy that provides scientists with new insights into how galaxies evolve through mergers and starbursts. ARP 220 has effectively become a living laboratory, showing how gravitational forces and star formation shape galaxies over billions of years. Even more astonishing discoveries awaited. As astronomers carefully examined the spectral data transmitted by the James Webb Space Telescope, they stumbled upon something extraordinary: primordial galaxies at the very edge of the observable universe. These galaxies were not just distant, they were ancient, relics of a time when the universe was still in its infancy, only a few 100 million years old. In cosmic terms, that's a blink after the Big Bang, a moment when matter and energy were still organizing into the first coherent structures, when the first stars were igniting and galaxies were beginning to emerge from the primordial darkness. At first, skepticism ran high. Could these faint points of light truly represent galaxies so far away in both space and time? Or were they illusions, nearby galaxies whose light had been distorted, amplified, or reddened in ways that tricked even the most advanced instruments? Could subtle instrumental effects, cosmic dust, or gravitational lensing be giving the illusion of extreme distance? But as the data was cross-verified with multiple instruments, with Webb's infrared observations carefully calibrated against Hubble and ground-based telescopes, it became increasingly clear. These galaxies were real, and they were astonishingly ancient. Their light, stretched and reddened by billions of years of cosmic expansion, carried with it the fingerprints of the early universe, the chemical signatures of the first stars, hints of nascent star clusters, and the primordial gas clouds that seeded the formation of entire galaxies. For the scientific community, this was nothing short of revolutionary. The implications were profound. These ancient galaxies offered a window into an epoch that had previously been inaccessible, a time when the universe was a fraction of its current age. Observing them allows scientists to trace the earliest stages of galaxy formation, to understand how matter coalesced into the first stellar systems, and to examine the processes that shaped the cosmic web, the vast, filamentary network of gas, dark matter, and galaxies that structures the universe on the largest scales. Every observation from Webb revealed more layers of complexity. Within these primordial galaxies, astronomers detected surprisingly high levels of star formation, far beyond what many cosmological models had predicted. Some galaxies, compact and tiny by today's standards, were producing stars at astonishing rates, hundreds of times faster than the Milky Way currently does. This early efficiency suggests that the first galaxies were already highly organized, capable of forming stars and complex structures far earlier than previously believed. Moreover, Webb's infrared eyes allowed scientists to detect the presence of warm dust and molecular gases, key ingredients for star formation, in galaxies that existed when the universe was less than 1 billion years old. These discoveries challenge the conventional timelines of cosmic evolution, implying that the processes leading to galaxy growth and chemical enrichment were already underway in ways that models had underestimated. The light from these galaxies also revealed subtle distortions, gravitational lensing effects from invisible dark matter halos, giving scientists a unique opportunity to map the unseen scaffolding of the early universe. In essence, Webb was not just observing galaxies, it was allowing humanity to trace the very blueprint of cosmic structure, to see the first strokes in the painting of the universe. Beyond the scientific details, there was an almost poetic wonder in these observations. Each photon reaching Webb had traveled across 13 billion years of space and time, crossing unimaginable distances to deliver a message from the cosmos's youth. The galaxies themselves glimmered faintly in infrared light, faint echoes of fiery starbursts, silent witnesses to the birth of complexity in the universe. Observing them was akin to looking back through time itself, seeing not just stars and galaxies, but the processes that would eventually lead to planets, chemical complexity, and perhaps life. As astronomers continued to process and interpret the data, more questions arose than answers. How did these galaxies assemble so rapidly? What mechanisms drove the early bursts of star formation? Were these primordial structures the seeds of the massive galaxies we see today, or did many of them fade away, leaving only subtle traces in the cosmic web? Each answer seemed to generate deeper mysteries, highlighting how much of the early universe remains hidden, just beyond the threshold of our knowledge. And yet, despite the scientific challenges, the discoveries carried a profound sense of inspiration. They remind us that the universe is far more dynamic, creative, and complex than we had imagined. Each glimpse into the ancient cosmos expands our perspective, reshaping our understanding of cosmic history, and forcing us to reconsider the very processes that led from a hot, uniform early universe to the intricate tapestry of stars, galaxies, and interstellar clouds that now fill the night sky. In the end, the James Webb Space Telescope's observations of these primordial galaxies do more than provide data. They offer a narrative of cosmic evolution written in light, stretching across billions of years. They show humanity that we are observers of a story far grander than ourselves, a story that began long before our planet formed and will continue long after we are gone. Each discovery is a reminder of the universe's boundless potential, and of the infinite mysteries that await those who dare to look deeper, to follow the faint light to the very edge of creation. Through Webb, we are not merely seeing the universe as it is. We are witnessing the universe as it once was, and in doing so, glimpsing the forces that shaped everything we know. And perhaps, in that distant light, we see the blueprint for what is yet to come.